page 143, we are looking at using a different type of method, proportional reasoning, to convert units. So proportional reasoning is when you actually know one of the proportions, a ratio rather, and you're going to use it to figure out an unknown value. So I think the easiest way to do this is to explain using an example. So three students were asked to convert 300 centimeters into meters. So here are their methods. All of them knew that 1 meter is equal to 100 centimeters. So this is the proportion that we know. You have to know that. You can use that as a fraction. So you have to understand that these two things are actually the same. So Alice said, well, I don't know how many meters this is going to be, so I'm going to put that in for x, but I do know that 1 meter is over 100 centimeters. And I want to know how many meters would be 300 centimeters. So notice how she has lined up her centimeters in the bottom and her meters in the top, because meters is what she's after here. So she has set this up correctly. And what she's decided to do in order to make these match is times the top by 3 and the bottom by 3 in order to make the match. And she comes to the conclusion that x has to be 3 meters. So that's one way to set it up. Jim has set it up exactly the same way. He said 1 meter is 100 centimeters. There's my proportion. I want to know how many meters is 300 centimeters. But he has decided to solve for x. And solving for x means we need to get rid of this denominator. So he's multiplied both sides by 300 to try and get rid of the denominator and isolate for x. So that's what he has done over here. And he gets the same answer. X is 300 over 100, so x is going to be 3 meters. And he's set up the meters in the top, centimeters in the bottom. This is very good. He has matched the units in the top and the bottom. Rima has set it up a little bit differently. They've decided to set it up with the centimeters in the top and the meters in the bottom. This is also perfectly okay. You can do it that way so long as both the tops are centimeters and both the bottoms are meters. The only issue with this here is it's a little bit difficult to solve for this because x is in the bottom. But if you've been paying attention in Math 10C, you'll know that you can just multiply both sides by x to get x in the top. And then you can divide both sides by 100 to isolate for x. So 300 over 100, again, is going to be 3 meters. So whichever method you use, you are going to get the same answer. And all of them are correct, but I would say that Jim's makes the most sense, and it is the easiest because it had the x in the top. Let's do a few more examples of proportional reasoning. This example says a photograph of an African elephant has a scale of 1 centimeter represents 0.6 meters. So they've actually given us the conversion factor. And it is not on a chart. It's a very specific conversion factor. So they had to give it to us here. The elephant's trunk in the photograph measures 3.5 centimeters. What is the actual length of the elephant's trunk? So they must want this in meters. The photo is in centimeters, but the real elephant is in meters. So we have some options of how we want to set this up. We could set it up like this. Here's our proportion on this side. And we could set it up so that the meters are here. So the unknown is x, meters in the bottom. And we can set up 3.5 centimeters in the top. However, that's going to be a little bit ugly because x is in the bottom. So it's just not my preference. It's not wrong. You can do it that way. But my preference would be to flip it. And I would do 0.6 meters in the top over 1 centimeter. So there's the proportion they've given me is equal to x over 3.5 centimeters. So my centimeters in the bottom, meters in the top. Now to isolate for x, I'm just going to multiply both sides by 3.5. And so x is equal to 0.6 times 3.5. And x is going to be 2.1 meters. So the reason you would use proportional reasoning instead of just a number line is because sometimes they give you a proportion like this that doesn't appear in a number line. It's very specific to the problem. And that's why we would use this. Class example number 6. Reba followed a recipe for rice bean soup. she is supposed to use 175 beans and 650 rice. So that's the proportion. So 175 beans is equal to 650 rice in a recipe. She didn't make enough, so she wanted to add 70 milliliters of beans to the soup. So 70 beans, and they want to know how much rice should I add. So if we want to set this up with X in the top because it's more convenient, we're going to put X amounts of rice in the top and 70 beans in the bottom because that's the amount I added on. Then we're going to use a proportion and we're going to set up another fraction. Make sure the rice is in the top as well this time. So 650 rice over 175 beans. I've put in the units so that you can see that I've set it up correctly. Rice in the top, beans in the bottom. But when you actually want to solve this, maybe we delete the units just to make it easier for us to see what's going on here. So here's our proportional reasoning. We can multiply both sides by 70 to get x. So x is 650 times 70 divided by 175. So it looks like x is going to be 260 of the rice, milliliters of rice.